Unreal Engine is a state-of-the-art game engine. To program it, there's a visual programming interface called Blueprints. To use this, you create new nodes and connect them together using virtual wires. In this example, we're creating a network where when you press the F key, it will spawn an object at the given target point. These nodes are very visual using drag and drop. Obviously, this makes it very hard for visually impaired learners to use. For the other students though, they find it very easy to create very complex games in a short amount of time, such as this example. When you press the key, a box appears. You press the key again and you get more boxes. Again, this is very visually appealing and the students are very engaged with using this environment. To convert this so we can have visually impaired students using it, you select the whole network and put it into this Python script. The Python script will then convert it into 3D models. These 3D models can then be opened in a tool called OpenSCAD, which will create an exact replica of the node, which can then be 3D printed. In this case, we've got the spawn actor from class node. As you can see, in Unreal Engine Blueprint Editor, they look very similar. This node can then be rendered. In this case it took 8 minutes, and that will then be put into a program called Slicer, which will convert the 3D model into a form usable by a 3D printer. In this case we're using Prontoface, which will take 7 3/4 hours to print. So an alternative we looked at was breaking it down so we don't print the base, we only print the text and braille. In this case, it's got the text and the braille with a flat bottom and the connection nodes. When these are rendered, it takes 12 minutes, and that will then be put into the next part of the tool chain, which is Slicer, which again converts it from the 3D model into a form used by the 3D printer. We can also convert it from one model into component parts, so we can print off one part or selected parts. In this case, the print time is now down to 4 hours. We're printing small things, such as this, we're looking at a quarter of an hour, which is more viable. We did look at using Lego connectors for the models, so we can convert the network node into Lego pieces, which then go on to individual Lego boards. Okay, the first version we did was printing everything on a 3D printer. So you can see we've got quite a thickness. We've got the text at the bottom and then the braille. This is something which is quite durable and will last. On the bottom we've got a QR code so the student can work independently more. That was fine, but that took about 3 hours to print, so we had to find some way to optimise that. Okay, next thing we did, we tried to print thinner. So it's a thinner base. The trouble is we'll lose all the stability and it falls apart quite easily and the things come off. So next thing we tried to do is just print the text and braille parts with a flat back. We can then stick it on something else. Our first idea was sticking it on foam board using Velcro, but again, this is not ideal, it's all wobbly and the pins, they fall off quite easily. We tried printing out blank ones so we can put the details on using braille. Again, these took quite a while to print, and it was hard putting on the text. Good old Lego. We got the nose printed out with Lego connectors. We got generic bases that we could interchange with Lego connectors, and then we can just place these on there and it's a lot faster. So to print something, all we need to do is print out the connectors and the text. Everything else just connects on as we need. That was okay, but it takes a long time to print Lego connectors. So even though the bases are interchangeable, it takes a long time to print these out. We print out the blocks separately with the text and the braille, and we'll mount those on Perspex block that we can just get cut to order. It's cheap, quick to do, and it's a good quality result at the moment. On the bottom we've got non-slip matting so it doesn't slide around, and still the QR code. That's where we are currently. We're still working out how to move forward with this to make something that's interchangeable. Whereabouts do we change? How many boxes spawn?
On the folder.
Yeah, okay, so where's the folder? Okay. Yeah. If you follow the data pin for the last index, and see where it goes to. What's the value of that one?
Oh, okay. Yeah. It's far.
Oh, okay. Shall we change that to a bigger number?
Yeah.
Okay. How many do you want on there instead?
So this is for how many boxes?
How many boxes are you going to spawn? You can go up to 16 because we've only made 16 boxes.
Alright, I'll do 10.
10, okay, 10's a good number. So I'll put it on there. And we've now got 10. So if I write on there 10, would you check that to make sure it says 10 to you as well? Did I get it right?
Yeah, it is.
Okay. Would you wire that in then to the for loop? Okay.
Okay.
So what's that going to do now?
That would spawn 10 boxes.
Okay.
So
if we want to spawn somewhere else,
yeah.
what will we move in the game level?
We'd move where this here says target.
Yeah. That's it.
Okay, then.
And then go to very, very far right.
Way too
See
high.
the 16? Change that to 10. That's good. Enter.
Okay, the radio falls kind of.
Okay, and then you see the compile with a question mark? In the top, very, very top. And go towards your right a little bit. The yellow question mark.
Oh, there.
No,
Oh, there,
that's the
sorry.
one, yeah. That's it.
Just click on that.
Click on that, and then close that tab. So click on that bit there.
Is there a way I can change the code of the Explorer?
Click it upwards. That's it. Click on that. That's good. And then
No,
click on
where's
there.
it?
Hit F11.
F11.
And then turn your character around using the cursor keys. Okay, go up to the top of the stairs, go forward. And then turn him round. Keep on going round. And then turn your mouse, turn the mouse and then go round. So like click first. That's it.
Oh, yeah.
And then press step.
No, okay.
Okay. And then you got to turn on look behind you again.
Turn what side? Alright.
That's it. Do it again, press step. That again. That again. That's it. That's good, nice one. Okay, you've got the game level in front of you now, Callum.
Right.
And put the target point there where you want the boxes to spawn. Remember the target point in the blueprint?
Yeah.
So you just put that anywhere you want in the game.
Just anywhere in
Anywhere you
this
want
bit
it all in the game, yeah. You can even put it up the stairs if you want.
I'll put it there next.
Okay, okay. So your character, where's your character going to be when you start off? There's your character. You can put them anywhere you want.
Can put what?
So you can put them anywhere in the game level.
Alright.
So where's it going to start off? Okay? So when we play the game, it's going to start running your blueprints for the level blueprint.
Yeah.
When you press the key, do you remember which key it was for the key event?
F, I think it was.
F, that's
Yeah.
right, so that's a key event key. It's going to start running your code. And it's going to spawn, how many boxes can you remember?
10.
10 boxes.
Yeah.
And where's it going to spawn them near?
Around the target.
The target points, the target point's there. So the 10 boxes, as if by magic, they all appear. And they're spaced randomly around.
Yeah.
Can you feel where the boxes are?
Yep.
So you can see they're all sort of randomly spaced round about where the target point is.
Yeah.
Yeah? So how do you find it, Callum, going from the blueprint, so you can create something and then it affects what happens in the game level?
Yeah, it's I definitely understand it from these.
That's good. And you understand what the effects are of changing variables, for example?
Yeah?
So if you change the number of blocks, you get a different number of blocks.
Yeah. If you change like distance, you get they'll be random, they'll be spaced out in different ways.
Yeah, that's it.
Things like that.
Okay. Well. And how do you find the 3D printed resources for Unreal Engine blueprints?
Yeah, they're really good. It's really kind of simplified the code down.
Yeah.
You know, and showed me showed me how everything, what everyone else is seeing, basically how everything connects up and how everything runs.
Yeah. That's good. Anything else?